This video is intended to supplement the other videos and indicator variables by providing a visual illustration of the same ideas. Simple linear regression is the model to apply when you have a single continuous predictor variable and a single continuous outcome. We haven't covered simple linear regression yet, but I'm sure you're willing to stipulate that we can generate a straight line that provides a best fit to the data. This fit will look rather like this, and not like that. The line will have a slope and an intercept. We'll call the intercept beta naught and the slope beta 1. We already know that the t-test compares the means of two groups. I've appended the mean outcomes for group A and B on this slide. All that differs from the usual presentation is that, instead of just labeling the groups as A and B, I've arbitrarily assigned values of 1 and 0 to a predictor variable labeled x. We'll see in a moment that these 1s and 0s are going to work out very conveniently. But for now, the point is that there's no reason I can't treat x as a continuously scaled predictor, even though it only has two possible values, and I can fit a simple linear regression line. Moreover, I'd really like that line to pass through the means of the two groups, as drawn. Here's a simpler version of the previous slide with the data points removed. The intercept, beta naught, is the value of y when x equals 0. In other words, it should be the mean of group B, which in turn is the reference group. Recalling the definition of the slope as the change in y associated with 1 unit change in x, please notice that going from group B to group A is also to make a 1 unit change in x. So the mean of group A becomes beta naught plus beta 1, as drawn. This slide summarizes the argument in symbols and essentially summarizes what was presented in the other slides. To extend this idea from two groups to three, in other words from the t-test to the one-way analysis of variance, simply create more than one indicator variable. Please notice that group C is the reference group in both the pictures, and the intercept beta naught is the same. The slope coefficient for x1, namely beta 1, quantifies the difference between the mean outcomes for groups A and C. Similarly, the slope coefficient for x2, namely beta 2, quantifies the difference between the mean outcomes for groups B and C. This slide basically just summarizes the argument in words. Which of course still raises the question, okay, so all of this works, but why in the world should I go to all this trouble? The main reason is that indicator variables allow us to unify the treatment of continuous and categorical predictors. For example, when we begin to consider analysis strategy for models with lots of predictors, we don't have to derive different strategies for different types of predictor variables. Our first dividend will actually appear in the module in the two-way analysis of variance. There we can quantify something called an interaction between two predictor variables, presently undefined, by simply multiplying the indicator variables associated with those predictors.